Generic greetings and welcome to Science Insanity, a channel dedicated to bringing my love of science fiction and all its technical complexity to you, the viewer. Today's topic was selected by Sci's patrons and is on the mechanics and physical design aspects of sci-fi ship design. This is the second video, or I guess the part 2 for the original, that was on the artistic principles and aesthetics of ship design. So if you're interested in seeing part 1, go check that out first to learn about why spaceships look the way they do before coming back here to learn about why they are the way they are, I guess. Okay, whatever. This video, however, will not be covering everything because I nearly drove myself insane. I was trying to write about every possible aspect about said ships and had to take a step back and reevaluate my life when I realized I had just finished writing 10,000 words on the structural challenges and issues when large voids, i.e. hangars, need to exist. If it isn't obvious, I haven't slept in weeks, so instead, just engines. All about engines. Ooh. First, we have no time for dallying, but Sci has a Patreon, please support, thank you. We have a Discord if you want to hang out with nerds whenever I manage to recoup my week's worth of lost sleep, and I'm streaming on the 24th, Armored Core, awesome, linked in the description down below. Okay, sad Sci hours are over, on to the actual video. Now, to start off with, I need to give a fair warning right at the beginning. This is going to involve a bit of my opinion, but will have quite a bit of real-world physics and design in there as well, and how they're translated into science fiction and the common elements of said designs between. Also, for any engineers or physicists in the comments, please don't rip me apart. I am but a dumb man trying to cover things to other very dumb people in layman's speak. I am also a nerd talking about spaceships, please cut me some slack. Also, this is going to ignore a lot of soft sci-fi tropes and ships, since space magic sci-fi can just wave their hands, say a wizard did it, and any engineering problems are gone. Treasure Planet is a great movie, by the way. Watch it. The first thing I want to do is explain the difference between a regular rocket engine and a tractor engine. No, not the kind stealing tanks in Ukraine. Essentially, a regular engine pushes the space frame forward from the bottom, relative, filling the role of the ground in a physical reference frame. Everything else on the ship sits atop the engine like a building sitting on the ground. A tractor engine is situated on the front or upper middle of the space frame and acts like the tension wires in a suspension bridge. It's pulling the space frame along underneath it. A wonderful example of this would be the design of several Imperial transport and supply ships from Star Wars. These big triangular ships, because everything has to be a triangle when you're talking about the Empire, have 3 engines on the hull, while a massive cargo deck extends back, or in this case, below the ship. The fundamental difference in these 2 engines is the forces they apply and the different design challenges they present. While regular engines would keep the entire ship in a state of compression, and to a degree you could theoretically build a ship with no attachments whatsoever, like not connect any of the panels, and the pure force of the acceleration would press everything together, a tractor engine would keep the entire ship, or most of it, in a state of tension, the forces being exerted on the front of the ship and all the other components hanging off the relative bottom. While this may seem like a bad thing, since you're essentially hanging the ship out behind you, and most people generally view construction as building up, not hanging down, the reality is that steel, like most of the metallic alloys and substances we use in construction and design, are actually for the most part stronger in tension than they are in compression and can resist more force before the structure is compromised or fails. In real life, the reason we used reinforced concrete is because the stony, gravelly concrete is amazing in compression and supports the weight of the building, while the rebar and steel beam framing give the structure tensile strength, allowing it to flex and bend to a degree without breaking. Ships using tractor engine setups like the freighter would technically be able to suspend more weight behind the engines like this than they would be able to push using the same materials. Despite this kind of setup having a few big advantages, tractor engines present a huge problem for rockets. Several of them, namely, things are in the goddamn way. The engine exhaust coming from most sci-fi ships tends to be extremely dangerous, so having the engine on the front of your ship means you're putting everything behind it at risk of melting. You also suffer the issue of needing to pump the fuel up against the apparent force of gravity, i.e. the thrust, and all of the mechanics that go along with that, but not super relevant, so Long story short, engine on front of ship, melt rest of ship. So what you're going to have to end up doing if you're using tractor engines on your ship is putting them significantly off-center and preferably forwards of where they need to be in order to get around this problem. But the real advantage these things have is hauling or towing things. Attaching a towing cable of any kind or hauling equipment to the sides of a rocket is a really, really bad idea because similar to only having one rocket on the side of your ship, it's going to throw off the stability and cause your ship to spin wildly out of control, and bare minimum, you'll need a second thrust cone at 90 degrees to keep things stable. By using multiple engines like this, you can tow objects behind the ship by simply mounting the towing cables or whatever directly in between the engines to completely bypass the stability problem entirely. By bringing your engines out and forward, use the space between them to safely attach things to. And speaking of, let's talk about the engine placement at the back of the ship to the more regular type of engines now, shall we? We won't touch on how you can place tractor engines since you really only have one option, so go nuts, I guess. But back onto the regular rockets, let's start with how many of them you're going to use. And honestly, it's the choice between one big central one or several medium or smaller ones. And there's, two ways you can go about that depending on the design. If the ship is small, you may only need a single engine capable of vectoring its thrust. Any changes in the center of mass due to people moving around, new holes in the ship, munitions being fired, all of that can be compensated for by micro adjustments. But for a much larger ship, they often use tons of engines, many of them, all over the place. Why is that? Well, aside from looking cool and generating enough thrust to move the ship, it's about stability and space. The ship has a center of mass. If the engine's thrust point is lined up with the center of mass, then the ship is stable. If it's not, you end up gradually turning, or your actual flight pattern is unstable. Multiple engines create a line between them. If the center of mass is along this line, the ship is similarly stable. 3 or more engines create a shape. Obviously, the more engines you have, the less taxing it also is on each one to counteract any shifts in the center of mass, like bits getting blown off the ship or cargo being loaded unevenly, or to compensate for, simply accelerating the ship. A giant brick of a spacecraft loaded in armor and guns and stuff is going to be an absolute nightmare to move around. So having one big engine, probably going to be a lot more stress on a single point of failure than having 4 or 5 medium engines that collectively generate the same force and push the ship at about the same speed. If you're using multiple engines, you also have the ability to turn some of them off. Maybe you don't need the ship to be cruising around at maximum speed at all times. Maybe it's significantly more efficient to only be using, for example, 2 out of the 5 engines you put on the back of the thing, and so you power most of them off to save on energy or skimp on fuel prices. Really, there's so many different reasons about why, or even perhaps you have different engines that are good at different things. Maybe you have smaller thrusters that put out a shitload of force, but can only do it for a limited amount of time, so you use those ones for maneuvering around tight areas, or you use them to get off the surface of a planet, and then you get the big ones that are designed to operate all the time to then push you around in space, just like the old multi-stage rockets that they used to have to get the shuttle into space. The small ones boost the thing up to get into orbit, and then the big one does the majority of the lifting. Also, going back to maneuvering for a second here, the rocket engines are capable of vectoring their thrust cones, so if you put them all at the back, you'll get something like an X-Wing, which can maneuver, but does it in slow arcs as the ship gradually turns itself around, at least compared to how hard spaceships can maneuver. If you intentionally offset the engines, however, and mirror them correctly, doing the opposite of everything we've talked about, you can get something like the Star Fury from Babylon 5. Offsetting the engines really far away from the center of mass might be super unstable, but it also generates a shitload of rotational force. If you fire 2 thrusters on opposite side rotationally from one another, then you can spin the ship along its axis for much faster maneuvering, while the main engine only has to end up pushing you directly forwards. So in many cases, depending on how you set up your engines and what additional thrusters you add and how they're placed along the ship, my god, that was a sentence, why did I write it like that? You can drastically change what your ship is going to be good at in the terms of how it's maneuvering and how it's accelerating. I should also mention that while this will apply to most sci-fi ships, There are still engine designs like those in Star Trek or other mostly science fantasy settings where forward is a tenuous concept and the engine can maneuver the ship in ways that are borderline impossible or in full 3 dimensions. In a lot of these settings, the design of your propulsion is mostly up to your in-universe explanation of what you think looks cool. But moving on, let's talk about what's actually going to power your engines, because this is something that's really cool and I think needs to be paid more attention to in sci-fi, especially if you're making harder sci-fi, because it's so goddamn interesting. So, the different ways that you can fuel your monstrous propulsion. First is with charged particles, a sci-fi classic. Second is with chemical reactions, the real-life holdover. And third is just outright space magic. Starting with the last one because it's the easiest to deal with, and this is all the nebulous, never-explained methods of locomoting, like an inertial drive. How the hell a ship can induce velocity without a counterforce? No idea. How can it warp space-time to create a gravity field pulling the ship along? No idea. How do any of these things work? A wizard did it. That's all you really need to know. For the most part, these types of engines are extremely rare, as they are quite literally physics-breaking, hand-wavium-fueled nightmares that only work if you stop thinking about them. And thus, we don't have much to cover, because I'm going to follow my own advice. I'm not going to think about it anymore. And let's get to the most common type for low sci-fi or near-future science fiction. Chemical reactions. These are essentially where a ship carries along a bunch of solid, liquid, or gaseous material that it can combust or otherwise react to produce thrust as the reaction product expands. The reason these are called chemical reaction engines in general is because they require you to carry and sacrifice a shitload of mass directly through some kind of combustion reaction in order to produce thrust in the process, consuming said material and losing them to the void. These types of rockets will usually need a shitload of fuel carried along with the ship in order to run, and I do mean astronomically huge amounts of fuel. Real-life rocket engines like the Saturn V would burn almost 10 tons of fuel every second when they were firing, which is why the fuel tanks were the size of a small apartment building on those things. So if you're someone who's creating sci-fi designs, then it's going to be a relatively low sci-fi setting where it's just maybe 100 years in the future or so, or even less than that, put it 50 or 60 years in the future, then you might end up having spaceships that are like a solid 50-60% fuel storage, because that's what they need to maintain the level of consumption that their engines would actually need. Something like Space Engineers, which lets you put hydrogen rockets on everything and then very, very gently eats through the hydrogen supply over the course of multiple years. That's not realistic. That's not feasible to what it would be like in reality. And this, however, this part, the different types of fuel that you could use is pretty much getting entirely into the fluff and the lore and the writing of your design and however much you want to flavor things up. But different types of fuel can add different levels of danger to using your ship or that engine system, or extra excitement to potential fights. In real life, a very common rocket fuel mixture is kerosene and liquid oxygen as reaction mass. Kerosene is fine, it's whatever, just carry it in a big tank, pump it out, whatever, who cares. Liquid oxygen is a problem. It is not only extremely cold, like freeze you solid cold a la liquid nitrogen, but it's not inert like nitrogen is. It's essentially the acid from Aliens. It will oxidize everything around it so aggressively that it will literally melt anything from people to metals to components into dust and rust as the oxygen atoms seek out and bond with anything and everything they can. Oxygen is a very, very dangerous element if it's just left out there on its own. So liquid oxygen fuel pipe rupturing on your ship would be a very fast way and a very painful way to melt the internals into the world's most uncomfortable gazpacho soup. While that level of immersion is often far beyond sci-fi, it is a very cool thing to think about and can add a lot of flavor to your engagements. For example, maybe you're fighting a much older ship design. You get a lucky hit on one of its fuel transfer pipes, and it starts leaking this incredibly caustic, extremely damaging fuel mixture all over the ship. You can have some real drama with the crew of that less advanced ship trying to keep this absolute hell compound contained. Maybe it knocks the ship out entirely as it disables some vital electronics or something. But instead of it being a big explosion, you have to wait a few minutes in your fight scene for it to slowly eat through the conduits or power transfer relays or whatever sci-fi bullshittery you end up inventing. So while this part is probably never going to be used by sci-fi writers ever because that's way too much detail to bother with, it is still really cool. I think it would be interesting to include and talk about. And with that, let's move on to ion engines or charged particle engines. These ones are weird and cool. Essentially, they rely on generating an opposing charge. A fusion engine generating a shitload of charged particles through its fusion reaction would generate not only power through electrons, i.e. electricity, but also a form of reaction mass. Say the proton is released into a chamber with a positively charged plate on one end. That proton would be repelled out the other end of the chamber, and because physics is the most fanatic conservationist known to reality, the chamber would experience the exact same counterforce of electromagnetic repulsion. That was a sentence and a very overinflated egotistical way of me saying, magnets, they repel, ooh, cool. If you do this with enough charged particles, then the chamber effectively becomes an engine, pushing the ship forward while ejecting said particles out into space, often generating that eerie bluish-white glow that you love to see through sci-fi. The differences and downsides between these two propulsion types are multitude, but for the most part, there's really just two big ones. Chemical rockets need a shitload more fuel and raw space to make them actually efficient over long distances and timescales, or even workable at all. And while a fusion reactor for an ion engine would still take up a lot of space, it's not that much. On the other hand, the ion engine would need an absolutely monstrous amount of energy pumped into it to generate even anywhere remotely close to useful thrust. And fun fact, we actually have real-life ion engines that aren't science fiction anymore. It's also technically possible to build one at home using conducting wires, batteries, and a tubular plastic frame. The problem is they rely on having an atmosphere to pump particles through it that they can then ionize using that electricity in those wires rather than... You know what? Not important. Moving on. The problem is that they generate a sum total force about as much as someone gently breathing on you. There are plans and designs that NASA is currently researching to try to make a nuclear-powered ion engine for very, very long time frame probes. We're talking like hundreds of years kind of probes that are going to go way out there into space powered by these little ion engines and essentially propelling themselves with the equivalent of a soft fart. In fact, I would highly recommend you check out this video by another way better channel than me, the Plasma channel, which is where I actually first learned of this like over a year ago, I think, and there are plenty of other examples you can find from channels like Real Engineering and stuff out there as well. So there's plenty out there to look at. Really cool. Highly recommend that you go check it out. I will link Plasma Channel's video down in a pinned comment. And with that, moving on to how you would actually mount these engines to your ship. Not in terms of forwards, backwards, on the sides, etc., whatever. I mean integrating them into the hull itself. And as far as I see it, there's three main ways that you can go about doing this. First is full integration. This is what real rockets use right now. The engine, fuel, pumping, and insulation systems are all fully and totally contained within the ship's hull plating, seamlessly fitting into the profile and only exposing the bare minimum of the thrust cone and any other machinery or components that needs to be out the bottom. You can see examples of stuff like this with UNSC ships from Halo. The Pillar of Autumn has two main engines and about a dozen smaller secondary engines, all of which are slotted firmly into the ship itself, entirely protected by the hull's armor plating. The most instantly noticeable reason for doing this is protecting them. In real life, it's because there are a lot of things that could potentially impact the rocket and do damage, but it's also to make an aerodynamic profile to reduce drag and energy spent getting the thing into space. In sci-fi, the primary purpose would probably be protecting your engines from things like missiles or bullets, debris, shrapnel, the quantum obliterator, all the things that pose a danger to your spaceships and that are relatively common to run into out there in the void. That's the plus side of this style of engine integration. It keeps them safe. And while the downside is that all of the internal components need to take up that space, meaning you'll either need to make your ship way bigger to accommodate for it, or skimp on space for the non-essential systems like the crew quarters, amenities, and luxury. The second type is semi-detached. These are engines that retain the majority of the internal system directly attached to them or very close by, while making some extra space on the internals by moving the actual thrust cone and a lot of that machinery out to armored pods externally on the ship. The easiest way to convey this is with the Battlestar Galactica. It has two main central engines integrated into the hull itself, the first category we talked about, while the four engine pods sit on the corners. They are closely attached, and it is visibly obvious that there are many tie-ins, components, and pipes leading to the central assembly, but they're not actually taking up internal space. They simply built a connection point for it, and then attached the engines on after that while working them into the profile. The Doniger is another excellent example. We know the Donnie's reactor is in the central rear of the ship, while each of the engines has been moved to the corners in order to free up space for the internal hangar bay we see storing all of the smaller support ships it carries along with it. These types of engines are the unhappy compromised middle ground. They're still protected, but often far less so as they need to be on the outside of the primary armor belt of the ship. As a trade-off though, they make lots of space for other important internals. The third type is essentially a full external engine pod. This is what you see on ships like the Galaxy class in Star Trek, suspended on these struts far away from the ship's core. But moving back to Halo, I think the best possible example I could give you is the Paris-class frigate. Its main engines are essentially entirely contained, with the power supply, all of the fuel, the reaction chambers, and all of the mechanics, all built together in one big brick, and then duplicated across the other side of the ship and extended in these big pods there. The actual assembly itself is super heavily armored, but not actually part of the main ship. It's like they built a second, smaller ship specifically for the engines to be in, then slapped it on a big tubular extension on the side of the ship. This third method of attaching the engines to the back of your space vessel is objectively the most vulnerable because most of the time you have to suspend them on these often very spindly struts reasonably far away from the ship itself. A good torpedo or a decent volley of weapons fire could probably take one of your engines clean off the ship right at the start of the fight if you get unlucky. However, it does provide a few benefits, and this is again delving into the very hard sci-fi stuff, but, well, you'd be very, very good at dissipating the heat from those engines by putting them way far away from the ship and slapping on a bajillion radiators. By indulging in the Space Dock Special, for anyone that knows him and his love of radiators, you could probably dissipate the majority of the heat without ever needing to impact the central core systems or the living areas of the main hull of the ship. That's pretty much the end of the video. That's covering all of the stuff I could think of on the engine design for sci-fi ships, how they're integrated, how they're used, the different ways you can mount them, the different types that there are, all of the neat weird things you can do with them, and even some tidbits of going into way more detail than is needed, like the fuel of it. And now, at the end, a thank you to all of the sadistic assholes that picked this topic for me to work on and basically forced me to do like a 4-hour video that I cut down to 30 minutes instead for 1 out of 6 topics. Woo! Thank you very much to all of this channel's patrons. I appreciate your support very much. With a special thank you to all of the patrons at the $5 tier: David G, the original, Augie, 11 Bravo Crunchy, Terry Higgins, Pedro Munaz, David G, the other one, Silencer, Vox Apollyon, Phoenix, BT Legend, Electroboy 11, Logan Maynard, Mickey, David Armand, Creedome, Robin Stappet, Fenrir Striker, Tachi Tukane, He's Deb, Pixie, Vertus, Fabric 445, Anchovy Bob, and making sure that Anchovy Bob is no longer sad on his own page, Mini Crustacean and Charles. Hooray! Now you have a proper third Patreon page. This list is getting so fucking long. Jesus Christ, man. Oh, the support you guys showed is genuinely really appreciated. Thank you very much. I hope your support will continue in the future. And with that, outros are hard. I'm tired. Goodbye.